Well, good morning, CHD. It is time for your favorite show, Doctors and Scientists. I'm your host, Dr. Brian Hooker, and autism is biomedical. Let's just get it straight here. Autism is biomedical. There is no ifs, ands, or buts about it. And so if you want to talk biomedical, then there's one person that you have to talk to, and that is Dr. Christian Bogner. Dr. Bogner, welcome to the show. Welcome back to the show. It has been like way too long. We should have had you on a long time ago. So Dr. Bogner is a practitioner here in Michigan, right?
Detroit, yep.
In Detroit. And you have been treating autism for how many years now?
Well, my son, probably 18 years, but just functional medicine-wise, talking with families for the last almost 8 years.
That is so incredible. Absolutely incredible. And the thing that I really appreciate about what you do is that it's progressive. That, you know, if things don't work, you're not using them. There are a lot of folks in this space, and when you're an autism dad like me, you're almost nomadic in terms of, you know, the different treatment modalities and the different practitioners that you look at. But your approach is so scientific. You're looking at what works, what doesn't work for your patients, and if it doesn't work, you've ditched it.
That's exactly right. Yeah, it's almost scary to look back. And, you know, when I started this, we threw a white net, and the things that we did, not that any of that was bad. It's just like, oh my God, you know, we were doing this all wrong. Dive into the water straight away, and instead of kind of having an overview of what's causing all of this. And yeah, and I'm sure we're going to look at this different in the next 5 years. But right. Yeah, it's exciting because, you know, once you have results and you see a patient do better, nothing is nicer in life right now than to see families heal, and it's beautiful. So that's what we live for.
Absolutely. Well, we had your colleague on the show several weeks ago. We talked about, you know, so many different things that that he was working on, you were working on. I want to talk about issues with mold, because I don't really see a whole lot of practitioners that are specifically looking at mold overgrowth and some of the toxic molds that our wonderful special children have been exposed to. So is it okay if we start there?
Yeah, absolutely. Anywhere, really.
Yeah.
So you have to do it, right? You have to start somewhere. Yeah, mold. I didn't know much about it. In 2019, you know, I was doing other things, neurotransmitters and genetics, and trying my luck there to find improvement. And then in 2019, a paper came out with Sidney Baker on the East Coast, together with Chris Shaw from back then Great Plains Laboratory, had a case report of a 4-year-old boy that recovered, and they used this medication, this antifungal medication called itraconazole, or the brand name Sporanox, which is actually, they pulled off the market now. They don't make it anymore, which is unfortunate. And all of a sudden, when that paper came out, I think it was November, December of 19, I got a lot of phone calls in my office. I'm like, oh my God, Dr. Bogner, did you see that paper? Can we do the same thing? And, you know, there was a 4-year-old boy that apparently recovered. And he had awesome. High mold toxins on the Great Plains Laboratory urine test. So there were mycotoxins that showed up. And they treated this boy with Sporanox, you know, relatively high doses. You know, they monitored his liver and all of that, and apparently he recovered. And so a lot of traction, not just in my office, nationwide, worldwide, really. And everybody wanted to have the same results. I did too. I was like, hey, if that's it, I'm all for it. Let's go. And of course, under a controlled environment, if you've supervised, there's really nothing wrong with that. You know,
right.
Counsel the parents correctly of what to expect and what needs to be done. You need to monitor liver and symptoms and stay in close touch with them. And I did that for about 2-3 years, extensive testing, and everybody had mold toxins in their urine.
Mm-hmm.
And we treated them with Sporanox, itraconazole, ketoconazole, amphotericin B, voriconazole, everything that's out there for mold. And it's just that, at least in my practice, couldn't reproduce the results that they had in that case report. So, and I haven't really met anyone so far that says, hey, I did the same thing and my child is recovered. Whatever.
Right.
But it's just wasn't really the answer. But that doesn't mean that there's no mold or mold
Right.
toxin. That's still an
Right.
issue. It's just the approach is just not reproducible. That's what I found.
I know that it's difficult as a practitioner to be able to assess stuff like this, unless you do some type of controlled trial. But did you hear anecdotally of any gains, where people see gains for that? So, I understand the concern. You tested my own son, you found black mold, species of black mold in his urine sample. And, we want to address that. It's toxic. It's absolutely wrong. He's never been treated for mold before. He had nystatin for yeast. Yeast is different than mold. And so, it's important to address that. But I really love the fact that you're so pragmatic and open about what you experienced and what you didn't experience.
It's a lot of trial and error. It's,
Right.
I always say autism is the ultimate disease. If you treat autism and you have results, you can treat pretty much everything else. But yeah, I mean, it's a huge problem.
Right.
United States, India, and China have the worst mold contamination of crops. It's billions of dollars lost every year because the FDA does have standards after each harvest for different types of mold toxins. There's parts per billion. Different mold types have different cutoffs, and early on in the season of cropping, when they see spores, they already cut a lot of the crops away to make sure it doesn't infest the rest of the crops. And so it's a big problem in that agricultural industry. And there's so much to it. We could have our discussion about this, but the bottom line is that about 90% of United States corn that ends up on the shelves in the supermarket, in your cereal, has more than one mold toxin present in it. Even if it's below, let's say, the safe limits. Okay, let's say we can prevent this. We can't just not do that. We would all starve to death.
Right.
But what is really that safe, limit? Because you, Brian, might metabolize and detoxify from those toxins without any issues, but Jimmy over here might not. And I think that's where we run into problems, when these mold toxins start to leak through the gut, stress the liver, make it into the blood, because it's very well established in the literature that mold toxins are not only linked to immunosuppression, but also to cancer, inflammation, chronic inflammation. And so it certainly doesn't help somebody that's already susceptible to toxins, to consume a lot of food that is contaminated with mold. And we're talking about soy, wheat, corn, alfalfa. All of them have been demonstrated to have toxins in it. And, in the industry, when a farmer, harvests the crops, they have to undergo testing. And let's say it's above, they have more mold toxins than what you're able to, before you send it to the processing facilities.
Right.
What can they do? Well, there are things you can do. You can bleach, for example. Bleaching is just cutting out the outer layer of the crops, and getting rid of that mold. But the shells and the outer shells of the crops, you have a lot of minerals. So that's why bleaching is not really good, because you have nutrient deficient crops. There are other methods. You can ozonize
Right.
the crops. Nobody does that. It's way too expensive. And
Sure.
so what I think, and don't quote me here, but what they most commonly do is they use corn that is known not to have mold, and they mix it until they reach a level that is acceptable per the FDA guidelines to then send to the processing facilities. And so you never really have United States crops without mold toxins. And who knows how strictly that is enforced? I don't know that, but
Right.
it certainly is an issue. And then what comes with it is that a lot of these crops are sprayed with glyphosate, and I think enough work has been done, with Stephanie Seneff and Zen Honeycutt, have done great work that, well, glyphosate is everywhere, right? It's in our food, it's in our prenatal vitamins, vaccines, breast milk, everywhere. It's ubiquitous. And so that comes along with it. It's a whole separate problem. But yeah, food is truly toxic, and it ends up in the urine of kids with autism, especially. And it's just, the bottom line is that, I'm not against treating. Some children are colonized, no doubt.
Right.
Mold in their sinuses or in the GI tract, and treatment is indicated. However, I'm not, when I would see that, I'm not testing for that anymore. But if I would see that in the urine test, it's not that I would immediately say, oh my God, let's treat. Because the issue really is, we all are exposed to this, right? But why is Jimmy developing autism and Johnny over here doesn't, even though they're brothers and they in the same environment, they eat the same food. And the bigger question is rather, why is Jimmy over here autistic? Why does he have a compromised immune system? Or it doesn't even have to be autism. Why does he have ADHD? Why does he have eczema and all of these issues? Rather than thinking about it of the toxic load, that Patricia Lemmer is always talking about, the total load.
Right.
Rather, what does Johnny have that Jimmy doesn't? And that is, the detoxification capacity, the liver, mostly. Why is one liver dealing with it better than the other? And we see it as their problems with children with autism. Very well that up to 90% of children with autism have GI issues. We can talk about that. That's what Alex probably eloquently explained, is that we find in all of the patients severe overgrowth of pathogenic bacteria that produce toxins that create a leak, right? And that leak, LPS is a toxin that's in gram-negative bacteria, is known to cause the leaky gut. And then all of these mold toxins that we consume, which you should have pooped out, they start to leak into the system. But even then, a neurotypical child can have Crohn's disease and leaky gut, all of that, and not be autistic. Why? There must be something else other than the gut issues. And that is the susceptibility, the genetic susceptibility of not being able to properly detox these toxins. And what we have found, as is that there are particular sulfation defects, particularly in the arena of the glutathione recycling.
Exactly. Right. Let's talk more about that, because, I think that this is such a consistent issue, is that the ratio between reduced glutathione and oxidized glutathione is completely dysregulated in so many children with autism. And you've addressed this, and you've addressed this head on. So talk to us about sodium thiosulfate.
Thiosulfate is a molecule. It's basically salt, sodium, and sulfur. And it's just a special bond between them. It's a double bond and an extra sulfur molecule. So it's a very strong bond. It makes it actually very reactive.
Right.
So we are able to produce thiosulfate. Actually, our body produces it primarily for detoxifying cyanides that are naturally occurring. Cassava, lima beans, even cruciferous vegetables contain naturally occurring cyanides.
Right.
We produce thiosulfate to get rid of that. And the problem is this: when we have toxins come in from the gut, right? Everything coming that's absorbed through the gut, except under the tongue and rectum, right? But mostly adult 20-foot GI tube, Everything that gets absorbed has to go through the liver, like border control, right? And because the liver is trying to prevent that anything that's coming through, and it's not just mold toxins or LPS or heavy metals or industrial chemicals or food proteins like casein and gluten, most of everything, the liver's trying to prevent that those antigens, I guess, reach the blood, because they would reach the blood. You would have the same reaction as if there's kind of a mosquito bite injecting its toxin, causing a histamine reaction, itching, redness, right? The same happens if the liver would let any of those pass. The immune system is like, you're not supposed to be here. And there's a mast cell reaction, histamine gets released, serotonin gets released. And we know that these mold toxins, for example, inhibit the immune system. So in one way, you stimulate the immune system, the allergic type of reaction, and the other side, you inhibit it. Inhibiting class switching, antibody production, natural killer cells, and so forth. And you wonder, oh, my kid never gets sick. Well, it's because the immune system is not reacting to the virus or certain other, pathogens. And that's why your child may seem like it never gets sick, although they're still autistic. So when these toxins are coming in, the liver is doing a phenomenal job. I mean, we're, exposed to all of these things, and we live, 100 years, knock on wood. And the immune system, keeps us alive. But when these toxins come in, glutathione is one of the major binding mechanisms of detecting those toxins coming in, and it binds them. And the glutathione, what it does, it donates a sulfur, one of its sulfur ions, to the toxin, which makes the toxin less negatively charged, which makes it more excretable through the urine, or you push it back into the bile, back into the gut. And the problem with that is that the glutathione then has lost its sulfur ion, it's done its job, and it sacrificed itself, and now it's what we call oxidized, right? And that's what you mentioned, is that we have available glutathione, we call it reduced glutathione, and we have oxidized glutathione. It's like a car, a beautiful car, but no gas. It can't bind another toxin because it needs another sulfur ion. And so the glutathione ratio is very low in chronic inflammation or in autism. It's been demonstrated. Very low available, very high oxidized. And so what we found about 3 years ago, and I think we talked about that last time, was with actually the help of a God's child, Jacob, who's a nonverbal 9-year-old, who told us about a molecule. And that's the sodium thiosulfate. So how does that come into play? Well, if in ASD or in chronic inflammation, we have high levels of oxidized glutathione, obviously the conclusion is there's a problem with the recycling process, right? Because naturally the body can recycle, it can repair it, so it can bind another toxin. And as you know, glutathione has two major functions: binding toxins and reducing free radicals.
Right.
And so why is that maybe not working? Why is that maybe a big issue in chronic inflammation or in autism? Is because usually this repair mechanism is powered by NADPH. It's an enzyme.
Right.
NADPH is fairly difficult for the body to produce. There are no supplements directly that you can take to have NADPH. But where is it? Why is it not there? And the answer, in my opinion, is because NADPH has a higher affinity to bind to free radicals, to superoxide, O2-. It's basically rather wants to go to the house that's burning rather than preventing a fire in the house next to it. So when there is inflammation, NADPH says, oh, sorry, I got to take care of this first, and then we can recycle you later. And why would that be the case in autism? Well, that probably is some sort of trigger. What comes to mind? Vaccines, right? So vaccines induce an inflammatory response. And if you have a susceptibility not being able to detoxify, the NADPH gets sucked up into these free radicals.
Right.
And now the problem is usually the body has a secondary mechanism to recycle that oxidized glutathione in case the NADPH is not there. And that is thiosulfate. And we found that thiosulfate can recycle the glutathione. And we believe that a big portion of autism is the inability of these children to generate thiosulfate because of sulfation defects, possibly because of glyphosate and genetic, sulfite oxidase gene, for example, that they have issues with this. Because what we also found, Brian, and it's, we talked about that before briefly, is that we found anecdotally in about 20 patients that children have elevations of cyanide in their saliva. And we couldn't believe it, because once we used this molecule and we found results, Alex and I were like, we need to find out how this works. And so the first thing we found is like, oh my God, it recycles glutathione. Makes a lot of sense. You recycle it, you have more detoxification capacity, you reduce the inflammation. Amazing. You see great results. We very quickly saw good results in a lot of kids, more eye contact, they're calmer, less stimming, a lot of them gained words. And then we're like, okay, well, sodium thiosulfate is approved since 1939 by the FDA in the IV form to treat cyanide poisoning. And until today, 80 plus years later, if you have cyanide poisoning, you go to the ER, you get intravenous sodium thiosulfate. So it's been, 80 years. Safety, all of that, it's pretty safe to give intravenously. And we're like, well, there's no way that this could be the mechanism in autism. But of course, we had to find out if that's true or not. And so the problem was that in order to measure cyanide, if you go to the ER right now, and there are about 50,000 cases in the US annually, cyanide poisoning, mostly house fires, firefighters. And I called the ER and I'm like, hey, if I suspect somebody of cyanide poisoning, what do you do? And the ER attending told me, we don't measure cyanide, we measure lactic acid, because cyanide is a mitochondrial inhibitor, and you go into anaerobic glycolysis, you produce a lot of lactic acid, body needs to survive without oxygen, and it does that, and you die of lactic acidosis and cyanide poisoning. But so that's what they measure, because when you would draw blood and you want to measure cyanide, you would have to flash freeze the blood and then run it through a sequencer. So there's no way in an acute setting anybody over the last 80 years is doing cyanide testing. So there was no good way for us to test it, this hypothesis. Could it be true?
Right.
So we did the next best thing, and whatever, it's kind of garage medicine, but we ordered these water strip tests from Amazon, $10, which very accurately measures the cyanide levels, parts per million in water. The more cyanide is in the water, the more blue the strip will turn. And we're like, so we tested urine, 20 patients, everybody was negative. There was no cyanide in the urine detected. But when we checked saliva, everyone was positive. Deep blue on the strip, on the saliva. We tested, the parents. We tested neurotypical siblings. They were not even close as being as deep blue as the kids that we had in autism. And so we're like, oh my God, we need to call Brian. Remember that's when we called you?
Right, yes.
This all might not be true, but that's what we saw. And it started to click and click. It's like, wow, what does cyanide do? Oh, it's a mitochondrial blocker. Oh, we have enough studies that show that mitochondria are involved, right? Mitochondrial disease. And
absolutely.
Yeah, and so that's pretty much it, that we found that it might not only recycle the glutathione, but it also detoxifies cyanide. Then we found it also binds mercury, and it binds arsenic, lead, nickel.
In former Soviet states, they've known about this for a long time. I mean, not specifically for autism, but they used it a lot for different detoxification, including uranium detoxification from the fallout in Chernobyl. And so this is, I mean, I think it's just so genius. And I just have to applaud your scientific curiosity in this whole thing, in terms of, seeking things out, looking at cyanide poisoning and high cyanide levels in your autistic kids. I mean, that is absolutely incredible. And of course, you're administering sodium thiosulfite in a lotion now.
Yeah, it was difficult to get this, IV.
Oh, sure. Yeah.
And so then we tried oral, even though it's actually a GRAS, generally recognized as safe. Sodium thiosulfate is actually used in our food supply already as an antioxidant, in like dried fruits to prevent them from browning and things like that. But we're like, well, if you take it orally, actually a very high percentage of it gets degraded in the stomach. So it's inactivated. I swallowed 8 grams before. It's fine. But active. So we tried it in a lotion, lots of trial and error with Alex over the next year, because it's a very reactive molecule. So to keep it stable in a lotion was very difficult. And whatever, 3 chemists later, we developed it into a lotion, and it's not here to advertise anything or sell anything. It's just to present solutions for our kids. But it's been really the inspiration for us to keep going and develop other supplements. And we always say we wouldn't have found this without this Jacob.
Right. How old is Jacob now?
He's 9 or 10. He's 10 now, I think.
10 now. Okay. Absolutely incredible, non-speaking autistic child savant
with spelling.
Who told you about who spells told you about sodium thiosulfate. That is absolutely incredible. On the horizon, what else? I mean, just really quickly, give us a teaser of something else you're working on. I mean, I love you and Alex because you are the quintessential, and I'm not going to say mad scientist, but I am mad scientist. And your curiosity in terms of how to heal these kids is so insatiable.
Well, listen, I'm just a dad, Brian. I'm standing on the shoulders of great people like you. I learned so much. I mean, when did I meet you? Over 10 years ago.
Right.
But I have to say, I give probably all of the credit to Alex. I think Alex is probably one of the greatest geniuses of this century, to be honest. I have not. I've been working with him for 5 years now, but Alex is just nonstop, 24/7. I hardly keep up with his ideas and his vision, and he keeps digging deeper than anyone I've ever. He wants solutions. He has a child affected, and I mean, Alex has developed a system to very accurately analyze the ecosystem of your microbiome. And not only that, to capture that data, but to know what to do with it. He's constantly on the phone with parents and texting and emailing, and he's analyzing stool tests. We're developing our own stool test now. And I always say we because I work with him, but it's really Alex. He's written a software that interprets the raw data. It's like interpreting the raw data of a 23andMe gene test. Is detecting the genes of these bacteria, quantifying them, giving great reports. And then what makes it different is that he actually has an actionable plan. If you have, low levels or undetectable levels of Lactobacillus or bifido, there's literature that supports certain compounds and fibers that grow these bacteria. And he gives you a plan for 6 weeks, and then he retests and he measures of, improvements of symptoms. And if you do that over and over and over, eventually you really become an expert, and you can almost look at a patient, at the behavior, and say, oh, you have, bacteroides, or this is a Prevotella case, or this patient needs lactobacillus. And
incredible.
Really has become so, the interrelationships of these bacteria and everything, he has that really down, and he's getting just better and better and better with it. And that's just one thing. Alex is also building cold lasers.
Right. We have them in our house. Yes.
Oh yeah. Do you like it?
We do. I mean, we just started using it, but I'm really, really excited for the results. And I do want to interject really quickly. One of the most daunting tasks, old school, for any parent was doing a stool test. And the thing that is so nice about the test kit we got, I read it, was like, that's it. This is so easy. You can do this even if you have an affected child, a severely affected child. You can do this stool test every 6 weeks. Absolutely no problem. I was just flabbergasted.
It's no digging around. There's a rice corn size Q-tip, and that's all you need. It's really
all you need.
A long way. You can sequence this out, and it's very accurate. Better than the other methods that are used in the other stool tests. And I think Alex can very eloquently explain why that is. But that's that. He's building lasers, cold lasers, with having great results with those in combination, even with the gut balancing, because the red photons, they stimulate mitochondria to produce energy. And
right.
There was even some literature that showed that red photons, since we have receptors on the mitochondria, believe it or not, activates the same enzyme that's inhibited by cyanide. So they actually have even some literature saying that, red cold lasers could be utilized for the detoxification of cyanide. But besides that, we are very active with the parents that we work with, and we couldn't do it without them. We learned so much. We actually just visited 2 patients in San Francisco this weekend, Alex and I, and it's just nothing more beautiful than to actually see a patient and see the improvement, and listening to the parents, how it changed their lives, the family dynamics, just sleeping through the night, how much of a difference that can make. Or
right. Oh, it's incredible.
The child doesn't bite things that you can achieve with addressing the microbiome. So yeah, but we're very, very encouraged, and it's a very exciting field.
Well, I have to say, I have been talking to parents for such a long time about practitioners and how practitioners need to listen and learn from parents. So everything that you say is, this is the type of practitioner you want to see. This is the inquisitive scientist that is actually learning something from parents, because he knows that the parents are there 24/7. And that is, you've said a mouthful. You absolutely have said a mouthful. And I can't thank you so much, Christian, for coming on the show today and sharing what you've shared.
As an autism parent, very well, I think the most comforting thing that I ever heard and that I have is that, that you're not alone.
Right.
And if you really digest that a little bit, that you're not alone, that there are other parents out there that have the same struggles that you do every day, that can be very comforting. And, that gave me a lot of peace, because you can feel very isolated, like in a prison, right? Well, the rest of the world, goes to their soccer practices and celebrates graduation. Can't do that because you're locked at home. But just know you're not alone, and just know that there's a way out. There's improvement. It's very much possible. We see it. We have hundreds of testimonials. We have a foundation at Autism is Biomedical. Come visit us. Explore what we have shared there. We interview families. We hear it from them. You can read testimonials. It's not just us trying to tell you, hey, that's how it is, and later it doesn't work. No, we work on that feedback from the parents, and that's what we give back. With the foundation that we have, we don't want to just say we interview. We start from the beginning and let parents tell their journey. And I think that's the most powerful thing. Is seeing is believing, and it's undeniable. It's, I think, more powerful than any study, really.
Well, thank you again for joining us. It is such a pleasure always to have you on the show. There's so much more that we need to talk about, so please come back. And thank you, everyone, for watching this important episode of Doctors and Scientists. If you know somebody that has an affected child, they need to see this episode. If you know somebody that has an affected child, you need to see this episode. So spread the word, and thank you so much.
God bless you.